This is Deliverable 2B by cadets Hoyt, Pravaznik, and Raymond. Our agenda is as follows, talking about requirements 1, 2, 3, 4, 5, and then finally talking about one of our stations, Coldfoot Camp in Alaska, which we see significant global warming. In requirement 1, we use sidewind.unzip and untarp file Arctic files from pat.tar.gz. This gave us a readme file within Sidewind, which allowed us to learn more about the format of the data files, and gave us direction for the rest of the requirements. In requirement 2, we wrote a shell script. This filtered all the stations that were above the Arctic Circle. This shell script left us with 725 stations, which were all above 66.33 degrees latitude.
In requirement 3, we began analyzing the data. In doing this, we began by clearing any existing data outside of the station name column. We then used a for loop to examine all 725 stations located above the Arctic Circle. We then defined a new variable, myFile, that contained the data for each of these corresponding cells, which was then fed into the larger provided for loop in the provided information. In requirement 4, we created our own subroutine in VPA, here called slopes, which utilized the Excel worksheet function slope to calculate the slope of the line of the squares for every Arctic weather station. This was done via a for loop as well. We then printed the corresponding values in the column next to the station name, sorted the stations according to that slope, and the highest 5 were selected.
After recording the top 5 weather locations with the highest slope, we found that these locations were in Canada, Sweden, and Alaska. And so for requirement 5, we did a little extra research on one of the locations, Coldfoot Camp, Alaska. So we found this website, the NPS Alaska Planning and Designs for the Future with Climate Change. So basically this talked about how the permafrost that was originally in certain locations was melting at a rapid rate and causing infrastructure failure, such as buildings to tilt and roads to sink because of the changing soil under the structures. So I'll pull a couple quotes from this. First one, until recently, most National Park Service planners, engineers, and architects had not factored climate change into their design projects in Alaska. They didn't really need to look at this because it wasn't affecting their plans. And now, since it's changing at such a rapid rate, they're going to need to take it into account. Another quote, global warming has increased sea retreat and reduced albedo in summer, which accelerates melting of snow, ice, and permafrost. As you can see, this puts a lot of things at risk due to the soil composition change and threatens many areas. Please direct any questions to Cadets Hoyt, Pravaznik, and Raymond.